Ever feel like when you're building for the web, clicking, things happen, but what's really going on?
Yeah.
Today, we're diving deep into the world of internet protocols, the hidden language that makes the web work.
Yeah. It's crazy how many developers, work with the internet every day, but
Hmm.
don't really understand those foundational protocols.
Right.
It's like writing code, coding in a language that you don't fully grasp.
Exactly. And that's what this deep dive is all about. We'll be
Yeah.
looking at some of the most important TCP, UDP, HTTP, gRPC, QUIC.
Hmm.
These are the workhorses of the internet, each with their own, personality, their own role to play.
Right.
Think of it, it's like knowing the engine of your car.
Exactly.
You can drive
Right.
without it, but knowing how it works just makes you a better driver, maybe even a better mechanic.
Absolutely. Yeah. For developers, understanding these protocols is so crucial for building efficient, reliable, performant applications.
Yeah, for sure. Let's start with two of the most fundamental protocols, TCP and UDP. They're kind of like the delivery services of the internet.
Yeah, good analogy. TCP, or Transmission Control Protocol, is like that really meticulous postal service, guarantees delivery.
Hmm.
It carefully sets up a connection, numbers each packet, for order, and checks to make sure that no packages are lost. So it might be slower, but you know that everything is going to arrive intact.
So if we're sending like really sensitive information, like financial transactions,
Oh, yeah.
we would want to go with TCP.
Absolutely. TCP is essential for those applications where data integrity is absolutely critical.
Got it. Okay, but what if we need speed? Like let's say we're streaming video or something.
Then we'd probably want to look at UDP,
Yeah,
or
okay.
User Datagram Protocol. Think of this as like a street messenger on a bike, so fast and agile, but maybe they drop a flyer or two along the way.
Uh,
UDP just blasts out those data packets without all the setup and checking of TCP, making it way faster.
okay, so UDP is speedy, but potentially unreliable.
Right.
How do we as developers decide which to use?
Well, it really just boils down to the needs of your application. What are you prioritizing, right? Do you need absolute reliability or speed?
Right.
If a dropped packet here and there won't break things, then UDP might be the way to go. But for critical data, obviously TCP is the safer bet. So for instance, like online games, they often rely on UDP because a momentary glitch is, less frustrating than lag.
Makes sense. So knowing the pluses and minuses of each protocol is key for developers.
Totally. And it's not just about choosing the right protocol for your application. It's about understanding why certain tools and frameworks might be better suited for specific tasks. For example, if you're using a framework that defaults to TCP for all its network communication, understanding the implications of that can help you make informed decisions about performance optimizations.
Right. So it's not enough to just kind of know how to use the tools. It's good to know what's happening under the hood, and that helps us make, more informed choices as developers. Now let's move on to HTTP. It's kind of like, it's the language of the web,
Yeah.
but it's gone through quite a few upgrades over time.
It has. HTTP, or Hypertext Transfer Protocol, started pretty simple with, HTTP 1.0, which allowed only one request at a time. So imagine loading a web page and each image, had to be requested separately. It'd be slow.
Right. I remember those days, dial-up, waiting for an image to load pixel by pixel.
Yeah, yeah. Thankfully, we've come a long way from those days. So then came HTTP 1.1, which introduced persistent connections. That meant that the browser could keep a connection open to the server so it could send multiple requests without constantly having to establish new connections. And that, really sped things up considerably. And it also introduced pipelining, which allowed, multiple requests to be sent one after another without waiting for individual responses.
So HTTP 1.1 was a big step forward in terms of web performance.
Oh, absolutely. But, as websites became more and more complex with images, videos, and dynamic content, the limitations of HTTP 1.1 became apparent. That's where HTTP 2 came in.
Okay, and this is where things get really interesting. So what did HTTP 2 bring to the table?
HTTP 2 was a real game changer. It introduced multiplexing, which allows you to send multiple requests simultaneously over a single connection, right? Like having multiple lanes on a highway instead of everyone being stuck in a single lane.
That makes total sense. And I imagine that really improved page load times.
For sure. Dramatically reduces latency. It also introduced header compression, which reduces the size of those data packets, making them faster to transmit, which, that meant web pages could load faster and handle more dynamic content.
Okay, so HTTP 2 is all about speed and efficiency.
Yeah.
But the internet never really stands still, right?
Right.
So what about HTTP 3?
HTTP3 is the latest and greatest evolution, and it takes performance even further by leveraging a new transport protocol called QUIC. And this wasn't just about minor tweaks, it was about completely rethinking how data travels across the web.
Okay, so HTTP3 isn't just a refinement, it's a fundamental shift.
Exactly. HTTP3, by incorporating QUIC, aims to offer, faster connection establishment, improved congestion control, and even better security than its predecessors.
That's incredible. It sounds like understanding HTTP's evolution is essential for web developers.
Yeah, totally. Knowing the history of HTTP just gives you such insight into how the web got faster and more responsive. It can inform the choices that you make when you design and develop web applications.
Right, and that's why we're doing this deep dive, right? We need to understand those foundations upon which we build. Okay, we've talked about TCP, UDP, and the evolution of HTTP. Let's dive into gRPC, a protocol that's specifically designed for communication between machines, particularly in microservices architectures.
Right, so think of it this way. HTTP is like the general purpose language of the web, right?
Right.
While gRPC is more like a specialized language for machine-to-machine communication.
So if you're building microservices, gRPC is the preferred choice.
In a lot of cases, yes. Because gRPC is designed with machine-to-machine communication in mind,
Okay.
it's just inherently more efficient and performant than HTTP for those use cases.
What makes gRPC so efficient?
Well, first, it leverages those performance improvements of HTTP2, right, like multiplexing and header compression.
Ah.
But it also uses protocol buffers, which is a highly efficient way to serialize data, right? That means smaller message sizes, faster processing. And protocol buffers also enforce a strict data schema, which reduces errors and just makes the communication between those services more robust.
So it's not just about speed, it's about reliability and ensuring that the data is exchanged correctly between the services.
Exactly. And just imagine like building a system where different microservices need to exchange these complex data structures. Using gRPC with protocol buffers can drastically reduce the overhead associated with, data serialization and deserialization, and that results in some significant performance gains.
Okay, that makes sense. This is helpful for understanding why gRPC is such a popular choice for microservices architectures.
Absolutely. And as we move toward more distributed systems and complex architectures, understanding protocols like gRPC becomes even more important for developers.
It's like learning the secret handshake for efficient communication between the machines.
Exactly. So while HTTP might be the common language for the web, gRPC is that specialized language that allows machines to talk to each other in a highly performant and reliable manner.
Gotcha. So as developers, we need to know kind of when to use the general language and when to switch to the specialized language, depending on the task at hand.
Absolutely. And that brings us to our final protocol for today's deep dive, and that is QUIC. So remember how we talked about HTTP3 being built on top of QUIC? It's like the new kid on the block, and it's promising to change the way we think about speed and reliability on the web.
Yeah, I'm really curious to learn more about QUIC and why it's causing such a stir.
QUIC, which stands for QUIC UDP Internet Connections, is a new transport protocol, but it's built on top of UDP, right? And it aims to combine the speed of UDP with the reliability and security features of TCP.
So it's like getting the best of both worlds, the speed of a sports car with the safety features of a family sedan.
Yeah, great analogy. QUIC establishes a secure connection up front, similar to TCP, but does it much faster. It also has a built-in mechanism to recover from lost packets without disrupting the entire flow of data.
And that's a huge advantage, especially for applications that are sensitive to, latency and packet loss.
Yeah.
What are the implications of QUIC for web developers?
The impact on web performance is significant, which is why HTTP3 adopted it as its underlying transport protocol. And while it is relatively new, it's growing rapidly, with some major players like Google and Facebook already using it extensively.
So it's not just a theoretical concept, it's already being used out there in the real world by some of the biggest tech companies.
Yeah, absolutely. And as more browsers and servers implement QUIC support, its influence on web development is just going to continue to grow.
This is why we need to know the behind-the-scenes workings of the internet, right? It helps us stay ahead of the curve, anticipate the future of web development. Okay, that's a wrap for this part 1 of our deep dive into the world of internet protocols. We covered a lot of ground. From TCP and UDP to HTTP and gRPC and QUIC.
It's been great. We've seen how those protocols are the building blocks of the internet and how understanding their nuances can empower us to build better, more efficient applications.
Absolutely. Join us for part 2, where we'll see these protocols in action, explore some real-world examples of how they're used in different applications.
Yeah. Looking forward to it.
See you next time.
See ha! Welcome back to our deep dive into the world of internet protocols.
Last time, we kind of laid the groundwork, getting to grips with some of the key players, TCP, UDP, HTTP, gRPC, even that rising star QUIC.
Yeah.
And it's pretty amazing how much we just take for granted when we're browsing the web, using apps, all that.
It really is. But for us as developers, understanding these underlying protocols isn't just about appreciating the complexity. It's about making informed decisions,
Yeah.
decisions that impact performance, reliability, security, all of that, of the applications that we build.
Exactly. It's like knowing the difference between a screwdriver and a hammer. You need the right tool for the job. So let's get practical today and see how these protocols actually shape those digital experiences that we have every single day.
Yeah, sounds good. Let's start with something like email. So when you hit send, you just expect that message to reach its destination, right? No question. That need for reliability points us towards TCP.
Right. Email is not something we want disappearing into the void.
Exactly. TCP ensures that every single bit of data, your message, attachments, everything arrives in the recipient's inbox intact.
So even if there's, network hiccups along the way, TCP is kind of working in the background to resend any lost packets and make sure that whole email gets delivered.
Right, exactly. It's like having a dedicated postal worker, meticulously tracking every piece of mail, making sure it reaches its destination, even if it takes a couple of detours along the way.
Okay, that level of reliability is pretty crucial for something as important as email. Now, what about something like video streaming? I imagine speed is pretty important there.
Oh, absolutely. For smooth video, you don't want to be waiting for every single packet to be acknowledged before sending the next one.
Right.
That's just going to lead to constant buffering and a very frustrating experience.
Right. So TCP's kind of meticulous approach wouldn't really work very well for video streaming.
Not really. Video streaming platforms generally rely on UDP speed, right? Remember, UDP prioritizes speed over guaranteed delivery, just blasting out those data packets as fast as it can.
Okay. But what about the packets that, inevitably get lost along the way? Doesn't that mean you end up with, like, choppy video, missing frames,
To some extent, yes. But video codecs, those are the algorithms that are used to compress and decompress video data. They're actually designed to handle some degree of packet loss without, completely falling apart.
Okay, so they can kind of fill in the gaps, so to speak.
Exactly. They interpolate that missing information and smooth out those minor glitches, minimizing the impact on your viewing experience.
So it's a calculated trade-off, right? A few drop packets here and there are acceptable if it means smoother video playback.
Exactly. It's all about optimizing for the specific needs of the application. Now let's think about online gaming, another area where speed is absolutely crucial.
Oh, for sure. In a fast-paced game, lag can be the difference between victory and defeat.
Exactly. Every millisecond counts. Imagine you're playing like a first-person shooter, and your actions are delayed because the game is waiting for those confirmations from the server. It would be unplayable.
So UDP is king in the world of online gaming.
In most cases, yes. UDP allows for those real-time updates about player positions, actions, game events, minimizing lag, and just creating a much more responsive, immersive experience.
Okay, but wouldn't that lead to some issues with cheating? The game is relying on the client to be sending these updates?
That's a great point. And it is something that game developers need to think about very carefully. While UDP is awesome for speed, it can be vulnerable to exploitation if it's not implemented correctly.
Right.
Developers often use different techniques like server-side validation of player actions, anti-cheat mechanisms, all of that just to mitigate those risks.
So it's not just about picking a protocol and calling it a day, right? It's about understanding those security implications and implementing the appropriate safeguards.
Absolutely. Security is a critical consideration in any application. And your choice of protocol can play a significant role in your overall security strategy.
Okay. Now let's shift our focus to something a bit more behind the scenes. APIs. We talked about gRPC being well suited for communication between machines, especially in those microservices architectures.
Right.
But what about public-facing APIs?
That's a great question. For public-facing APIs, HTTP is still the dominant protocol.
Okay.
It's just so widely adopted, it's so versatile, and that human-readable format,
You're
it
right.
makes it a really practical choice for developers.
But didn't we say earlier that gRPC is, more efficient for machine-to-machine communication?
We did, yes. But public APIs often need to be accessible to a wider range of clients and developers.
Okay.
HTTP's well-established ecosystem and tooling just makes it easier for developers to integrate with and debug.
Gotcha. So while gRPC might be the speed demon for internal communication, HTTP is, kind of the reliable workhorse for those public-facing APIs.
Exactly. HTTP just provides that familiar and well-supported foundation for building APIs that are accessible to a broad audience.
Okay, so before we wrap up this part, I want to circle back to QUIC. We've talked about its potential to really shake things up in web performance, but how is it actually being used today?
Well, while it's still relatively new, QUIC is already being used by some really big players in the tech industry. For example, Google uses QUIC extensively for their own services,
Wow.
including Google Search, YouTube, Gmail.
So they're not just talking the talk, they're walking the walk.
Exactly. And other companies like Facebook and Cloudflare, they're also adopting QUIC.
Okay.
And as more browsers and servers implement QUIC support, we can expect to see, much wider adoption in the near future.
It's really exciting to see how QUIC is shaping the future of the web. All right, that's it for part 2 of our deep dive.
Yeah.
We've explored how internet protocols are actually used in those real-world applications like email, video streaming, online gaming, APIs, all of that. And we've seen how understanding those protocols and the trade-offs that they involve can really help us make informed decisions as developers. Choosing the right tool for the job, building better, more performant applications.
Absolutely. So much to consider.
Yeah, for sure. So join us for the final part of our deep dive where we're going to bring everything together and we're going to discuss the bigger picture of internet protocols and really how they impact the world of software development.
It's going to be great. Looking forward to it.
See you next time. Welcome back to the final part of our deep dive into internet protocols. It's been quite a journey, exploring this hidden language of the web.
It really has. We've gone from the fundamentals of TCP and UDP all the way to the evolution of HTTP and the emergence of these, more specialized protocols like gRPC and QUIC.
Yeah, and we've seen how these protocols actually shape the applications we use every single day,
Mm.
and how understanding their little quirks can help make us better developers.
Absolutely.
Yeah.
Now, as we wrap up, I want to kind of shift our focus from those technical details to the bigger picture. So what are some of the key takeaways from our deep dive? What should developers keep in mind as they navigate this ever-evolving landscape?
Yeah, it's really easy to get lost in the weeds, when we're talking about protocols.
Yeah.
But stepping back and seeing the forest for the trees is really crucial.
One of the most important takeaways here is that there's no one-size-fits-all solution. When it
Yeah.
comes to internet protocols, each one has its own strengths and weaknesses.
Right.
And the best choice really depends on the specific requirements of the application you're building.
It's all about understanding those trade-offs, right?
Right. Mhm.
Reliability, speed, efficiency, complexity.
Exactly. For example, if you need absolute reliability for something like financial transactions,
Right.
then TCP is going to be your go-to protocol. But if speed is paramount, like in online gaming or video streaming, then UDP might be the better choice.
And for machine-to-machine communication, we've got gRPC, which offers significant advantages over HTTP in terms of performance and efficiency.
Hmm.
But for those public-facing APIs, HTTP's versatility and wide adoption still make it, a strong contender.
Another key takeaway here is that the world of internet protocols, it's constantly evolving.
Yeah.
New protocols emerge, existing ones get updated, best practices change, all of that.
It's like any other area of technology. We've got
Yeah.
to stay curious, keep learning, and be adaptable.
I completely agree. QUIC is a perfect example of this, right? It's a relatively new protocol, but it's already making waves, and it has the potential to really impact web performance in the coming years.
Yeah, it really highlights the importance of continuous learning for developers.
Mm.
We can't just rely on what we learned in school or even, a few years ago.
Right.
We got to keep our fingers on the pulse and be ready to adapt to these new technologies and new paradigms.
I couldn't agree more. The field of software development is constantly evolving, and internet protocols are no exception. Developers who embrace continuous learning and stay up to date, they'll have a huge advantage when it comes to building those, robust, efficient, and future-proof applications.
So as we wrap up this deep dive, I really want to emphasize the importance of not just knowing how to use these protocols, but understanding why they work the way they do.
Yeah, it's not enough to just know which protocol to use for a given task. We need to understand those underlying mechanisms, the trade-offs involved, and the potential pitfalls that might come up.
It's kind of like, the difference between knowing how to drive a car and understanding how the engine works.
Exactly. Knowing how that engine works allows you to troubleshoot problems, make informed decisions about maintenance, and even maybe even modify the car to better suit your needs.
Right. So in the same way, understanding these internet protocols at a deeper level, it empowers us to build better, more efficient, more reliable applications.
Absolutely. It allows us to anticipate those potential bottlenecks,
Yeah.
optimize for performance, and just make better choices about security and scalability.
So as you continue on your journey as a developer,
Yeah.
you know, remember that the world of internet protocols is this fascinating, ever-evolving landscape.
Yeah.
Don't be afraid to dive in, explore those nuances, and challenge your assumptions.
By understanding the hidden language of the web, we can really unlock new possibilities and build those truly innovative applications that, that push the boundaries of what's possible.
It's been an awesome journey exploring the world behind the web, and we hope this deep dive has given you a better understanding of how internet protocols work and, why they matter so much for developers. See you next time.